Imagine a journey through endless darkness, where notions of distance and time lose all meaning to our finite perceptions, where the Milky Way, that familiar name we so casually invoke, is in truth a grand and languid dance of approximately 400 billion stars, a structure that has endured for more than 13 billion years, a span so immense that even light, the swiftest entity in the cosmos, requires at least 100,000 years to traverse it from one side to the other, and the vastness coupled with the profound historical depth of this galaxy not only surpasses our capacity for imagination but also renders every human achievement on this diminutive planet akin to a fleeting blink, a momentary flicker amidst a multitude of enigmas awaiting discovery. And at the very heart of that colossal ocean of stars, some 27,000 light-years distant from the modest position of our solar system, a distance that light itself would take 27,000 years to cross, lies a region of space dense and enigmatic, a place that scientists term the Hidden Heart, where, according to the most recent investigations from the James Webb Space Telescope and the Event Horizon Telescope network, it serves not merely as a vast forge of elements but also as a natural laboratory for testing the extremes of physical theories. When we gaze upon the night sky from Earth, as inhabitants nestled within the galactic disk and peering towards the center, we perceive only a faint band of light, a delicate milky streak obscured by thick interstellar dust clouds. Yet this is the subtle indication, the faint exhalation of a mighty elemental forge. And recent observations from the James Webb Space Telescope have unveiled that this region harbors the Sagittarius B2 molecular cloud, the largest star-forming cloud in the galaxy, responsible for birthing half of the new stars at the center, with massive luminous stars and glittering gas dust illuminated in infrared light, demonstrating that the radiance emanates not solely from the black hole but from intense stellar birth processes. In this central domain, the stellar density is not a mere handful of stars per cubic light-year, but a staggering figure of approximately 290,000 solar masses crammed into a single cubic light-year. Envisage, if you will, an imaginary cube with sides of 1 light-year in length placed there, and the mass compacted within it would equate to nearly 300,000 suns. And fresh research from the University of Cologne reveals that even dusty binary objects like D9, identified in the year 2024, can sustain stable orbits despite colossal tidal forces, suggesting that the galactic center is less destructive than previously supposed, thereby opening possibilities for complex structures to persist longer than anticipated. What force, with what authority, could compel and sustain such a terrifying concentration of those immense plasma spheres? The answer resides not in the ordinary gravitational resonance among individual stars, but in a singularity, and not in space-time before which all modern physical theories must yield. And updates from the Event Horizon Telescope network in the year 2024 have disclosed powerful spiraling magnetic fields around the black hole's edge, akin to those in the M87 black hole, indicating that magnetic fields may shape the infalling matter streams, enhancing the radiant intensity through electromagnetic radiation. The exploration of this hotspot commenced with faint echoes in the electromagnetic spectrum, not until the year 1964, a pivotal milestone marked by the American scientist Cloud and his 2 colleagues, who, with equipment rudimentary by today's standards, fortuitously detected a potent and brilliant radio source emanating from the direction of the constellation Sagittarius, precisely towards the galactic center. Astonishingly, this source exhibited an extraordinarily rapid variability cycle, completing a rotation in merely 11 minutes, such swift rotation implying an object of exceedingly small size yet possessing enormous mass, far exceeding what any ordinary star could attain without collapsing, and subsequent studies from the year 2025 suggest this black hole may once have had an intermediate mass companion black hole, engulfed when our galaxy absorbed a dwarf galaxy, accounting for part of its activity fluctuations. Many decades later, deeper inquiries guided by more sophisticated observational instruments led to incontrovertible confirmations, particularly the work of the German scientist Reinhold Genzel and his associates through precise tracking of orbital motions of stars near the center, these stars hurtling at velocities reaching thousands of kilometers per second, providing the clearest evidence of an unparalleled gravitational field. And more recently, observations from the James Webb Space Telescope have recorded eruptions from the black hole, with brilliant infrared light, revealing that Sagittarius A is more active than predicted, possibly feeding on nearby stars. These intricate measurements have demonstrated that at the Milky Way center resides a compact, non-luminous object in visible light, yet estimated to possess a mass of 4 million times that of our Sun, a gravitational monster, cosmic burden compressed into an unimaginably tiny space, and new data from the Event Horizon Telescope network in the year 2025 have refined image resolution, unveiling finer details of the shadow region, aiding in detecting signatures of surrounding dark matter. And then a historic event unfolded on the 12th day of May in the year 2022, after years of data accumulation from across continents. The Global Event Horizon Telescope network announced its monumental achievement, the first image of the supermassive black hole at our galaxy's center, named Sagittarius A star or Sgr A, the image not depicting the black hole itself, for by definition, a black hole is a region from which nothing, not even light, can escape, but rather the absolute dark shadow, the rim of the no-return zone encircled by a glowing accretion disk of matter torn asunder and accelerated to near light speed before plunging into the abyss, that dark shadow being the imprint of the event horizon, the ultimate boundary before gravitational annihilation, and follow-up observations in the year 2024 incorporated polarized light data, revealing spiraling magnetic fields organizing the infalling matter, akin to a colossal energy channeling system. It is the inconceivable gravitational force of Sgr A that primarily engenders the bizarre radiant brilliance of the central region. Under that fierce pull, stellar density escalates to unbelievable levels, stars not only following stable orbits but also continually being shredded and devoured by the black hole, this process far from silent. When a star is elongated, the event termed spaghettification occurs, wherein the star's matter is drawn into a thin strand like pasta before falling in, yet not all matter plunges directly. Much becomes ensnared in a whirling accretion disk around the event horizon, compressed with extreme friction generating temperatures of billions of degrees Kelvin, emitting terrifying electromagnetic radiation from X-rays to gamma rays, rendering the galactic core one of the brightest and most violent locales in the entire Milky Way. And new research from the year 2025 indicates that stable dusty objects nearby may be remnants of torn stars, surviving due to magnetic field protection, challenging theories of total destruction. Furthermore, the matter density near the black hole is so profound that even stars drawn in do not vanish entirely from observation. They may interact beforehand or collide violently, forming ultradense matter clusters, temporary yet highly dynamic stellar clumps, these influenced by the potent gravitational field, emanating secondary fields outward, creating effects like perpetual stellar storms, agitating the interstellar medium and either expelling or drawing in gas and dust clouds, fostering a chaotic environment brimming with energy and radiation. And observations from the James Webb Space Telescope have illuminated Sagittarius B2 with newly born massive stars, proving that even amid chaos, star formation proceeds vigorously, potentially creating planets under harsh conditions. In an environment so severe that matter is rent asunder, temperatures soar, and ionizing radiation is intensely potent, the question of life's existence, even in its most rudimentary form, becomes almost moot. Consider the fundamental elements for carbon-based life as we understand it: firstly, liquid water, and secondly, a relatively stable setting for complex molecules to form and persist. At the Milky Way's center, these conditions are utterly inverted, yet recent discoveries of surviving objects near the black hole suggest perhaps small pockets of greater stability, though still too harsh for organic life. The fierce radiation from innumerable supergiant blue stars, short-lived yet shining millions of times brighter than the Sun, combined with emissions from Sgr A's accretion disk, would incinerate any nearby planet. Surface temperatures rising to preclude liquid water, it would evaporate instantly or freeze if thrust away from the primary heat source in the harsh vacuum. Atmospheres, if formed, would be stripped by powerful stellar winds and continuous bombardment from ultraviolet, gamma, and high-energy X-rays. Complex organic molecules foundational to life dismantled almost immediately by this ionizing radiation, everything sterilized to the atomic level. And studies from the year 2025 emphasize that despite stable binary stars, the radiation remains too intense to permit life development. If, by some means, a civilization had evolved in this ultra-dense core, their technological prowess on the Kardashev scale, proposed by the astronomer Nikolai Kardashev, would at minimum attain level 3. A level 1 civilization harnesses the entire energy of its home planet, level 2 the full energy of its host star, and level 3, by original definition, commands the energy of its entire galaxy. To endure the ceaseless destruction and colossal energy from the galactic core, such a civilization would necessitate constructing megastructures, perhaps galaxy-scale Dyson spheroids, not only for energy harvest but for complete shielding from lethal radiation, mastering physics at levels we scarcely dream of, perhaps exploiting zero-point energy or manipulating local spacetime to create stable habitat bubbles isolated from the external turmoil. And recent discussions on the Kardashev scale suggest that Type 3 civilizations might lurk in galactic centers, utilizing dark energy or concealing signatures to evade detection, explaining our lack of signals from them, with extensions proposing Type 4 controlling galaxy clusters and Type 5 the observable universe. Yet the harsh reality is that our position, that of humanity, is nowhere near that power center. Our solar system resides peacefully, or more accurately, safely distant, from the central madness, tucked in the inner edge of the Orion Arm, a minor spiral branch of the Milky Way, 27,000 light-years from the center, a separation sufficient for stellar density to diminish to levels allowing stable, long-lived stars like our Sun to prevail, and far enough for extreme radiation from Sgr A and other central sources to attenuate to tolerable levels. We inhabit what astronomers call the galactic suburbs, a relatively tranquil zone where stellar birth and death cycles unfold more gradually and predictably. The presence of liquid water on Earth, the formation of complex organic molecules, all direct outcomes of our fortunate placement in the so-called galactic habitable zone or gigahertz. And the latest research from the year 2025 shows the gigahertz to be broader than predicted, with stellar migration enhancing habitable planet potential in outer galactic regions, where radiation is scarcer and heavy elements more abundant, rendering the suburbs more ideal than the center. This imparts a profound realization, almost a collective humility to humankind. We pride ourselves on our cities, our edifices, our scientific insights, believing we stand at evolution's pinnacle in this universe, but contextualized within the Milky Way, a galaxy nearing 14 billion years old, we recognize ourselves as mere denizens of a small, safe neighborhood, our civilization just beginning to grapple with harnessing a single modest star's energy, while the galactic center, ostensibly the convergence of all evolution, is a furnace too ferocious to allow stable existence without godlike prowess, and new models of advanced civilizations suggest that if Type 3 entities exist there, they may have surmounted the Great Filter, self-destructed, or concealed themselves, accounting for the silence in SETI searches. What we pursue, wars, resource disputes, decades-long construction projects, viewed through the cosmic scale's lens, appear trivial and risible beyond description. Perhaps humanity's destiny is not conquest of the galactic center but our fragile persistence on the periphery, akin to a cold message from the universe. The emergence of organized intelligent life is an extraordinarily rare coincidence, a fortuitous randomness nurtured in a sufficiently quiet cradle, and with discoveries of Milky Way like galaxies early in the universe from the James Webb Space Telescope, we may infer that other galaxies possess similar habitable zones, where civilizations might develop without chaotic centers. That cradle, the Milky Way, operates by silent and eternal cyclic laws. Molecular clouds collapse to form new stars, stars live and die, scattering essential heavy elements for life into space, and all that matter eventually spirals back to the center, crushed by supreme gravity only to have its energy reborn as fierce radiation before the material might be reused in fresh star formation cycles in remoter regions or eternally swallowed by the black hole, and studies of femibubbles indicate historical eruptions from Sgr A still shape the galaxy's structure today, predicting that in the near cosmic future, the black hole may activate more intensely if it ingests additional matter. The birth of life, with all its biochemical complexity, is an astonishing miracle, a random alignment of physical and chemical laws over billions of years, but the death and vanishing of such life when confronting the universe's grandeur and indifference becomes fragile and vulnerable to a horrifying degree. The radiant brilliance at the Milky Way's center is not merely starlight or black hole energy, It is an eternal reminder of uncrossable boundaries that even the most advanced intellect must respect or face obliteration, and with findings of colossal synchronized spiral structures in the universe, perhaps the galactic center forms part of a larger network, where high-level civilizations traverse dark matter filaments. To broaden our vista on this brilliance, we must delve deeper into specific energy sources. The primary luminosity in the central region stems not only from Sgr A. Latest research drawing on data from the James Webb Space Telescope and other infrared observatories reveals the concentration of special case stars, the S-stars, orbiting the black hole at extreme speeds, some with orbital periods of mere hundreds of days. For instance, the star S2 or S0-2 completing a circuit around Sgr A in approximately 16 years. As these stars approach their periapsis, the closest orbital point, they endure immense gravitational influence, and this interaction, sometimes termed gravitational tidal forces, may melt or even tear their outer layers, releasing vast gas quantities into the accretion disk, amplifying X-ray and gamma-ray emissions, rendering the region brilliantly luminous in high-energy spectra. And recent James Webb Space Telescope observations have detected black hole eruptions, indicating this activity persists, potentially leading to larger outbursts in the future. Moreover, scientists are probing deeply into Sgr A's eruption phenomena. Though this black hole is presently relatively quiescent compared to active galactic nuclei in other galaxies, where emissions are far more potent, historical data show it has exploded vigorously. Studies from the year 2018 indicate that 300 to 500 years ago, Sgr A unleashed an extreme energy burst sufficient to ionize gas and dust in the central Milky Way, creating the vast Fermi bubbles observable in gamma-ray spectra today. This outburst may have been triggered by a large gas cloud or shredded star falling in recently, affirming the central region's high dynamical state, with radiation waxing or waning dependent on Sgr A's meals. And with new data from the year 2025, scientists predict that if the black hole consumes an old companion star, activity could multiply, impacting the entire galaxy. Consider the density contrast with our solar system's vicinity. Average stellar density is far lower. Within a radius of about 1,000 light-years around the Sun, it is merely 0.003 solar masses per cubic light-year. This disparity is enormous, nearly 10 million times the central matter density. This difference extends beyond star numbers to radiation pressure and collision frequency. In the suburbs, planets have billions of years to cool and stabilize atmospheres. At the center, stellar collisions might occur every few million years, and any orbiting planet would be annihilated or ejected from safe orbit in a galactic instant. Yet the discovery of the D9 binary and stable dusty objects suggests some microregions permit longer-lasting structures, though still unsuitable for life. From a theoretical standpoint, the Kardashev scale's level 3 requires expansion given the central galaxy's harshness. A civilization there might not only control galactic energy but master space-time manipulation. Theoretical physicists have posited further classes like level 4 harnessing galaxy cluster energy or level 5 the entire observable universe. A civilization enduring in the Milky Way's center might have achieved levels where they create stable wormholes for transit or employ dark energy to govern cosmic processes on grand scales. However, contending with the impenetrable gravity of a supermassive black hole remains a challenge. But Einstein's general relativity, once beyond the event horizon, all proceeds irreversibly towards the central singularity. Thus, intelligent life must operate outside the event horizon but within its extreme gravitational influence. Where energy derives from the accretion disk, they might utilize quantum physics and particle physics at unimaginable levels, such as extracting Hawking radiation from the black hole itself or leveraging extreme relativistic effects to maintain artificial habitat stability. And new speculations posit that Type 3 civilizations use the Kardashev scale as a luminosity bound, concealing signatures to avoid conflict, as in the dark forest hypothesis. From an observational perspective, the Event Horizon Telescope's image of Sgr A is visual proof of a supermassive mass entity, yet it also highlights the absence of visible complex structures. If a level 3 civilization operates actively there, harnessing galactic energy, they have likely masked their signatures perfectly or their technology produces no detectable excess electromagnetic radiation. The Great Filter hypothesis may apply here, perhaps attaining level 2 or 3 is the phase where most civilizations self-destruct via war or energy mismanagement before adapting to harsh environments, or maybe the galactic center is a gravitational trap, recycling everything and precluding long-term structures, and with large structures detected at galactic centers in the year 2025, these might signal artificial activity, though unconfirmed. Returning to our own diminutiveness, this cosmic humility is not an insult but an awakening. We dwell in a galactic safe zone, an oasis shielded by gas and dust disks, distant from nearby supernova blasts and the black hole's engulfment. Life on Earth has had approximately 4.3 billion years to evolve from simple cells to conscious beings, requiring the sun's energy stability and our galactic position's protection. If our solar system shifted slightly centerward, Earth might have become a dead world billions of years ago, scorched by stronger radiation from younger, hotter stars prevalent in the core or orbitally disrupted by more frequent stellar gravitational interactions. And gigahertz research shows outer galactic regions hold higher life potential due to stellar migration dispersing heavy elements outward, predicting life may be more common on the galaxy's rim where we reside. What we pursue, humanity's values and goals, viewed from the vantage of 13.6 billion years and 400 billion stars, seem frivolous games. This awareness compels us to confront the truth that our existence is a statistically extraordinary fortune. The universe is a colossal machine, a warm cradle yet emotionally frigid. It nurtures life through favorable local conditions like a sheltered garden amid a vast storm, while operating in ceaseless cycle of formation and destruction. Elements vital for life, such as iron, oxygen, and silicon, are forged in the deaths of massive stars via supernova explosions, their remnants dispersed, eventually aggregating into new stellar generations like our solar system. And with detections of early Milky Way-like galaxies, this cycle may have occurred faster in the primordial universe, leading to civilizations more ancient than we imagine. Life's emergence is a probabilistically minuscule event, a miracle of chemistry and physics, but its demise when facing unstoppable cosmic forces is nearly certain, an inevitable conclusion in time and space's grand flow. The Milky Way's central radiant but deadly brilliance is the most eloquent testament to that eternal opposition, one side boundless generative potential in safe zones, the other supreme concentration of energy and matter where complex forms are pulverized into primal simplicity. Our task, as suburban galactic dwellers, is to cherish this transient existence in our quiet yet peril-laden cosmic corner. And to deepen understanding of this extreme environment, consider the impacts of intense gravitational fields and radiation on matter physics at the core. General relativity's effects are no mere theory but governing reality. Time dilation is pronounced. If one astronaut nears Sgr A's event horizon and another remains distant, say at Earth's position, observing the same event, the distant observer would see it unfold far more slowly. Time near massive objects runs slower than in weaker fields. This affects not only biology but time-dependent physical processes like radioactive decay or chemical bond formation. A high-level civilization there might exploit this time dilation to extend computational processes or experiments lasting thousands of years by distant clocks, and measurements from S-stars have confirmed red and blue shifts due to relativity, bolstering Einstein's models. Additionally, from research on central objects, scientists have gauged subtle spectral shifts in S-stars caused by relativistic effects, the blue shift and red shift of light from these stars as they approach or recede from the black hole provide the strongest experimental evidence for Einstein's general relativity, further affirming the accuracy of models describing this extreme milieu. And with new Event Horizon Telescope data, we may anticipate observations of quantum effects near black holes, such as Hawking radiation, in the near future. In the context of extraterrestrial life studies, scientists have expanded the galactic habitable zone concept by considering factors beyond stellar density. The gigahertz is defined as the region where background radiation is sufficiently weak and heavy elements, metals, abundant enough for rocky planet formation, but not too near the center where supernovae are too frequent. The galactic core, with its excessive matter concentration, is entirely excluded from the gigahertz. Recent models suggest the gigahertz may be a ring-like structure, not overly broad, and we lie on its outer boundary. If we venture farther to the galactic disk's exterior, we encounter heavy element scarcity, leading to planets forming primarily as gas giants or lacking necessary rocky cores for Earth-like life, and research from the year 2025 shows stellar migration expands the gigahertz outward, multiplying habitable planet probabilities, predicting life may be more prevalent on the galactic rim where we are. The Milky Way's central brilliance, ultimately, is a spectacle of destruction transmuted into pure energy. It is physical evidence that supermassive black holes are the undisputed gravitational controllers of all major galaxies. If a level 3 civilization exists, they must master gravity, radiation, and perhaps spacetime's essence to survive there. However, from an Earth observer's viewpoint, this knowledge only accentuates our fragility. We, creatures dependent on a G-class star, a planet with a strong magnetic field shielding from solar winds, and an atmosphere rich in oxygen and nitrogen, striving to find meaning in the vast universe, that we detect Sgr A only via indirect signs of infalling matter and captured its event horizon's shadow merely in the year 2022 shows the chasm in knowledge between us and cosmic mysteries remains abyssal. And with updates from the Event Horizon Telescope in the year 2025, we edge closer to comprehending surrounding dark matter, potentially unlocking new universe theories. Humanity's destiny's cruelty seems to lie in needing abundant energy for peak development, yet the most energy-rich locale, the galactic center, forbids long-term complex structures. Life requires stability, found only in sheltered suburbs. This is an eternal cycle. Matter concentrates, burns, energy releases, and matter regenerates in remoter places. Might some high-level civilization observe us not from the Milky Way's center but from a hidden corner in this quiet suburb, smiling at our modest efforts to seek them? Or perhaps the silence from SETI is the answer. Only level 1 civilizations, still fumbling with planetary energy and unaware of high-energy zones' dangers, persist long enough to emit faint radio signals we might catch. Truly advanced, level 3 entities may have transcended radio needs or perfected concealment within cosmic background radiation, and with the Kardashev scale extended, humanity perhaps achieves level 0.7, far from 1, predicting that to ascend further, we must surmount energy barriers and avert self-destruction. The Milky Way's central radiant light is no invitation but a warning, a monument to matter's ultimate annihilation. It is where the universe's laws manifest most starkly. Supreme energy demands supreme sacrifice, and humanity, fortunately, is distant enough to continue dreaming. However humbling our tiny position, we are temporary survivors, protected by tens of thousands of light-years of dust and gas, endeavoring to learn from the very forge we are lucky to evade, and with ongoing discoveries. From the James Webb Space Telescope and Event Horizon Telescope, the future may bring sharper images of the center, aiding predictions of major cosmic changes like galaxy mergers, affecting the galactic habitable zone and civilization's long-term viability.